Okay. If I did everything correctly,
so at the airport, it was the same. It wasn't $60, but it was like $40 or something. And then it's like, oh wait, just updated this. What? And then I like closed the app and then went back into it. It's like,
okay, shall we? Good morning. Thank you for being here at 8:30 a.m. That's very impressive on your part. I had to be here, you didn't, so I really appreciate it. What I forgot, you forgot something with my clicker. Yes. It should just connect, maybe, possibly. Not really. We can force it. We have 90 minutes, we're fine. Sorry about that. I mean, 8:30 in the morning.
you said you're in East Coast time, so you don't really have this reason.
I'm actually central, so yeah, it's 9:30 for me. That's true. You got me. We're 1 hour difference. It doesn't work. Okay, I'm just. Now that's like, I don't like it. That doesn't work. Just maybe the button is there or something. Oh, it is what it is. I'm just going to fix it. Okay, so DevOps Reframed. What I'm going to present to you, or at least start with, is a conspiracy theory. I hope we will land something here, like in we have questions area, not going to the real heavy shit, but it will be an interesting theory. My name is Baruch Sadogurski. I'm at Baruch everywhere, and I'm a developer productivity advocate with Gradle. Started being a developer many years ago, and then with my previous company, with JFrog, that I'm sure you're familiar with, kind of moved into a DevOps space. Did a lot of years in this space, almost from the beginning where it became a thing, and now back to the development part of the house, working on advocating for developer productivity engineering. So I co-wrote a couple of books, the DevOps tools for Java developers and Liquid software. So this is obviously very relevant to our developer DevOps connection. And the thing to know about me, this is an amazing chart from an amazing book called The Culture Map. Anyone familiar with this book? You really, really should read it because we all work in multicultural companies and it's really good. This is one of the charts. It maps different cultures on emotional scale and confrontational scale. The most emotionally expressive and confrontational people are from Israel and Russia. I managed to be from both. So if I somehow offend you during this talk, the thing is I'm not even really sorry. So yeah, the most important slide of this talk is this. So if you go to speaking.jbaruch, you will find there the slides, the video, and all the links, including everything I already spoke about. The chart, the Culture Map book, both my books and what's not. So basically it looks like this. So if you go there, you will see, where's my mouse? Right here, you will see like the recent presentation is this, right? So you click on it and maybe loading, maybe, yeah, there you go. So the slides are there and then all the links, right? I will have the video if I record it correctly and my phone won't overheat and I put it in D&D so no one will call. But there are a lot of reasons why you won't have the recording. But fingers crossed you will, right after the talk, I will be able to put it here as well. So back to, yeah. So, you don't need to even remember this because it's in the bottom of every slide. So you can just go there whenever you like as my Twitter handle, and the hashtag DPE stands for Developer Productivity Engineering, and you will see why in a second. Right, so as I mentioned, I started as a developer many years ago in Israel, Java developer, and how many of you are developers? No. What are you doing, sir?
Tech director.
Tech director, excellent. Everybody else are developers, so my people, excellent. You have opinions about DevOps? I think. We'll talk about what those opinions are and why are they. But this talk will be perfect because I'm going to talk to you about those opinions. So, conspiracy theory. DevOps is a plot of ops people to make us, the developers, work harder. And I have proof. Exhibit A, the Phoenix Project. Are you familiar with this book? Yes. Really great book. It's a fiction about DevOps, right? Not fiction like in terms of it's not probable, but fiction like it's not documentary. The idea is that there is a guy in one company that got in charge of operations and basically releasing of software. The company is failing, he doesn't know what to do, and then he kind of invents DevOps and wins. That's like the premise of this book. Very well written, has obviously all the right ideas, explains what DevOps is, why it is important. If you didn't read it, I highly recommend it. There is an audio version if you prefer listening. Really, really good stuff. The idea of having like a fiction novel to explain a concept and most of the concept was directly stolen from another book, or should I say influenced by another book, remembering the culture map. And this book called Goal by Eliyahu Goldberg. It's the same idea, it's a novel about theory of constraints. With also the same premise of someone who got put in charge when everything is falling apart, and they kind of come up with this theory of constraints. So it's the same idea, just a theory of constraints evolved into DevOps. It's not only evolution for the book, it's actually the real evolution of the theory. DevOps is built a lot on this theory of constraints. So yeah, what I wanted to show you is what this book is really about. So you can see here on the cover, tons of people, and those people are the main, the main characters in the book. So by looking at the main characters, we can get an idea what this book is about. Right, so here on the back we have Patty, and she's the director of IT service support. IT service, she's an ops person, obviously. Her colleague, Wes, he is director of distributed technology ops. He's obviously an ops guy. And then we have Sarah Moulton, she is like the antagonist and she's in sales, obviously, an antagonist, she's in sales. And then we have Steve, who is the CEO, and he also fired his CIO when everything started to fall apart, so he is like an acting CIO. Dick Laundry, he is CFO, fine, and then this guy, Bill Palmer, he is the main protagonist of the story, and he is VP of IT Ops. He's an ops guy that kind of goes and invents DevOps and all this stuff. Right, and eventually by the end of it, because he succeeded, he actually aims to become the full-time CIO. Eric, the board member, he generally knows about the theory of constraints, so he goes, mumbles ideas into Bill's ears, and this is how Bill comes up with DevOps. And then there is Brent, and Brent, he is like the technical guru of the entire organization. They explain the buzz factor using Bill. He's so smart, so brilliant, but he's also like one guy that carries everything, and it's not a good idea. Anyway, he is a lead sysadmin, he's obviously ops. Right? Any observations? Oh yeah, and there is like the John, who is the chief security officer. You know, that everybody hates, that comes and complains that you're not allowed to do that, you're not allowed to do that, this kind of stuff. And he also comes around and like, oh, DevOps. No. Never mind. Observations about this one.
There's a massive wall between the developer and.
Oh yeah, no, I mean just the people and their roles.
No developers.
The most important book about DevOps. Well, they are there, but first of all, they are kind of on a back roll, and also they are not pictures in very good light. Trust me. Everybody hates them because they do their work and just go home. So yeah, the most important book about DevOps, and not a single developer in any like good or positive or main role. Exhibit number 2. Let's see who pushes DevOps to us. Who tries to explain to us why DevOps is important? So let's take a look. Amazon. Amazon is an ops platform. Atlassian. Atlassian is a DevOps platform. GitLab. GitLab is an ops platform. Microsoft. Microsoft is an ops platform. Who else? TechTarget, journalists fine, Wikipedia, obviously. Synopsys, ops tool. Logs.io, logging observability, ops concern. IBM, ops platform. I mean, by now, it should be really obvious. And every time you hear about DevOps, see DevOps, someone tries to sell you DevOps. It's all ops people wanting something. Now let's talk about why are they doing it. Why they push DevOps so hard. So first of all, what is DevOps? What this thing is about? So here is a great Quora question. As a Linux system administrator, how do I shift my career to DevOps? And this is one of the answers. And it goes like, well, first of all, you have great background, Linux administrator, that's all you need. Basically, you just go ahead and learn a bunch of stuff, something that's called Gits, whatever it is. Chef, Maven, Jenkins, Puppet, Docker, bunch of stuff in Gits here as well. Well, Gits is important apparently. And then after you being Linux administrator and learn Gits, you go from this to this. Now, obviously, that's a good incentive to learn Gits because you kind of almost double your salary just changing your title from Linux administrator to DevOps engineer. And next thing you know, this is like we are now economic downturn, massive layoffs, call it whatever you like. Still, as of today, 20,000 open positions for DevOps engineer in the United States. Because everybody wanted to be a DevOps engineer those days. And also, like there's a lot of money to be made. So let's make certifications for DevOps engineers. We will ask you Git questions and give you a nice diploma and you will pay for it. So this is awesome. Now, I have a personal beef with even the term DevOps engineer, and we're going to talk about that a lot in a second. But frankly, I don't think that DevOps actually came to be to kind of make money out of it. I think it's an effect that it's a booming industry now, but I think the cause is something else. What is the cause? So this is what it's called the DevOps infinity cycle. And it starts with plan, code, build, test, release, deploy, operate, monitor, and then goes on go further. Does it look familiar to you? Anyone has any ideas what it reminds them of? Yes?
Software development cycle.
Software development cycle. Here you go. Exactly the same. Plan, code, build, test, but without the operation cycle. So what DevOps is, hey folks, you do this part, great, but also go ahead and do this part, do our job, basically. this is what it looks to me. We were fine here. For some reason now, we also need to do this. They are also not very good in hiding. So this is one of the most important documents in DevOps kind of world. It's called the DORA DevOps Research and Assessment Institute State of DevOps Report. They've been doing it, I think, now for almost 10 years, 8 years, and this is kind of where you look if you want to understand where the industry stands in adopting DevOps. Now, by looking at this report, we can see what the DevOps people really think DevOps is. So here is how it looks like. This is from the old one, but I just love the layout of it. So we have here groups: elite, high, medium, and low performers. Doesn't matter. What matters is, so this is how they look at what's important. Obviously, new work, this is where you want to be. Because new work means you do something meaningful, you create new projects, you make more money for the company or whatever company goes up. Now, what else do we have? Remediating security issues, very important. Working on defects and identified by end users, fine. And then customer support work. This looks fine, right, for all of us. That makes perfect sense. The question is, what do they mean by each and every one of those? So they are explained in the report and in a book called Accelerate that explains the theory behind this report. Also a great book, very highly recommended. So types of work according to DevOps, to Project Phoenix, to the DORA report. Planned work, that's the new work, business projects and new features. Excellent, we can all get behind it. But then it becomes weirder. So internal projects, server migrations, software updates, and so on. Okay, not really our thing, is it? Server migrations. Changes. Driven by feedback on completed work. Fine. And then unplanned work, support escalations and emergency outages. I mean, this is all very fascinating. It just has nothing to do with what we do. What we do? Well, new features is writing code, refactoring is writing code, and bug fixes is writing code. No outages, no server migrations. All this stuff is really not our job. So, I think by now it's pretty clear that DevOps is a plot of ops people to make us do their job. Right? But what is our job? There are, I guess, each and every one of us have a definition of what a good developer should do. And there are a lot of definitions out there as well. I picked one that I particularly like, software craftsmanship movement. I don't know if you're familiar with it. There are some questions to the authors, whatever their reputation is, it doesn't really matter. I just love the list, right? The list makes a lot of sense to me. I hope it makes a lot of sense to you. Well-crafted software, good quality, steadily adding value, not just doing something for the sake of doing, but doing that with something valuable. Community of professionals, productive partnerships, makes perfect sense to me. And if you look kind of closer and make it a little bit more practical, that's the list I came up with, and you tell me how do you feel about it, right? So, software craft person definition of that. We understood the requirements. We know what we need to do, and then we write code that it's clear, well documented, concise, and all the good versions of clear code. We write code that is easy to deploy, and this is kind of our contribution to DevOps, right? We want it to be easy to deploy. Non-functional requirements are met, performance and what's not. We didn't incur new technical debt. We actually might reduce some of the old one by refactoring that we do. All the tests are passing, and then generally the entire QA department are happy with the quality of our work. That's important, right? Our team lead is happy, and then our product owner or whatever the proxy for customer in our organization is happy. Right? Did I nail it? Does it make sense? This is what we all try to do? Excellent. So now there is something that for me now is pretty obvious in 2023, and this is this part, that we work together with our testers in our organization because quality is a part of what we take ownership and pride. If you're old enough, you remember that that wasn't the case always. This is an old picture, but it's actually great. That shows some kind of a rivalry between developers and testers. Now, who thinks it makes sense that there is a rivalry between QA and developers? No, right? It's absurd. They are actually helping us, making our quality better. And this is our code. We take responsibility for the quality, so we are very grateful for them that they're helping us, right? There is no rivalry. It's like, yes, find the bugs, let me fix them. We are in this together. So we actually want, I don't know why I went into very old Soviet memes, but here we are. We really want to make software better, right? This is like very our goal. Now, what is quality software? This is, for me at least, a moving target. Because if we look back, for example, on a bank website. So this is Chase circa 2007. It looks obviously ridiculous to us now, but the interesting part there are two. First of all, I couldn't do a whole lot. I maybe could like check my balance, but that's like pretty much all. And also, it wasn't as critical as it is today, the banking software, right? So generally, I wouldn't be surprised to see here in news and announcements like, well, we need 12 hours maintenance window to update our software, and this is to ensure quality, obviously, right? And I would go like, well, fine, if I need something, I'll just go to the bank. Today, obviously, this won't fly, right? Well, this is not a quality software if it needs 12 hours maintenance window for updates. And I, for one, actually switched banks over the usability of a mobile app. Because this is how I do my banking and it's important for me. The old one was bad, the new one is better, so yes. And I know other people that do this. Now, the problem with ensuring quality today is not only that the requirements are changed, but the requirements of the users, the demands for quality and for what quality means, but also the software have changed. Today, code quality, just not having bugs, is not enough because we live in a world of big data that is getting bigger by an hour. Right, so this is a prediction by Seagate. They produce hard drives, so they might be biased. But whatever you look at it, and even if you divide it by whatever you want to divide it by 2025, they predict that the size of global data sphere is all the data that is stored like everywhere, will be 175 zettabytes. Now, zettabytes is a lot. When you think about big data, what are we thinking of? Petabytes, right? So, after petabytes, 1,000 petabytes is exabyte, and 1,000 exabytes is zettabytes. It's a lot. And although we might have a small part of it, even in our organizations, we have more and more data that represents, that is part of the software that runs in production. And that means that testing in a real life data without being in production is almost impossible. It used to be easy. We used to have the staging server. It was exactly the same in production. We tested everything there. And we had a very high confidence that when we take the software, put it in production, it will work the same. Because the software is the same, the data is the same, we're all good. No more. Because building a staging server that will have the same amount and the same type of data like production is impossible. It's too expensive. It doesn't make any sense. So how can we do what we do? And how can we as developers guarantee the quality if we don't have access to the environment which mimics production? There are two answers. The first is we're panicking. The second is we're going to production. There is an entire industry now of testing in production. There is a whole new class of tools that helps us do it. It's all called progressive delivery as a term. And you can see here a lot of canary deployments. That's like when we release to a small part of. So another story of canary, right? Why canary deployments is called canary. It's a story from the old days of very dangerous coal mining, when the miners were releasing the bird, the canary, into the what's it called?
Coal mine.
Yeah, into the mines to check if there are gases there, because the canary would die and they won't have to, right? So it's the same idea. Canary deployment is we release our software to a small percentage of unlucky users and see if they're dying. If they survive, that's probably fine. If they're dead now, well, oops, something went wrong. So it's the same idea, and I love those metaphors about like death and destruction. One more that I really like is blast radius. I love blast radius. It means that we're throwing things into production, it will probably go boom, and our goal is to minimize the casualties of our software. This is what it really means. I love it how like people think about it as it should be. Basically what I'm trying to say is something will go boom in production, those canaries will die, and the only way for us to ensure our quality in production is being there when the blast go boom and the canary dies. Basically what it means is that we are now the part of the incident response team that needs to be there when the canary dies and the blast go boom. There is no way we can avoid it if we consider quality as a part of our responsibility as developers. Now, it also affects how we write software. You remember this list? There is a new line here. DevOps are ahead. Before we go into what does it mean, so who is this DevOps person? Jokes aside, the kids and the Linux administrator. Who they are. And I mentioned that I really have opinions about this term, and this is the time to talk about it. I have an obsession. And my obsession is with the term DevOps engineer. DevOps engineer is not a thing. Cannot be in any shape or form. Because DevOps is a collaborative practice. It's a methodology. And the terms DevOps engineers make as much sense as the term collaboration engineer. It's not a thing, it cannot be. You know why? Because if you call those people, and we'll get to the right terms right now, if you call them DevOps engineers, what do you do next? Well, you put them in teams, and there will be your DevOps teams. And you might think, as a DevOps team, as like the most efficient DevOps engineer doing their DevOpsing thing, but what I think about is we just created another silo. So Silo is actually a book made very popular now by an Apple TV show called The Silo. Anyone watched it? No. So yeah. So it's basically anti-utopia about like a dystopian future. Well, basically like every other silo, including what we are doing, right? So Silo is on point. Dystopian TV show. In a ruined, toxic future, thousands live in a giant silo deep under Earth. This is your DevOps team. Right. So we just created another silo. And obviously silos are bad. And obviously now we are back to square one when developers write their code and then throw it over the wall to this silo where DevOps engineers are now trying to release it when the developers already went home and just on the beach drinking beer, do whatever they like. We are literally back to square one because someone thought that DevOps engineers would turn. Now, we obviously want to break down the silo. And how do we break the silo? We bring together the developers and the DevOps engineers. And we need an intern for that. How about DevOps? Right? So, this is bullshit. The entire thing of DevOps engineer is bullshit because it brings us to square one and builds this divider between developer team and DevOps team. DevOps team is not a thing, DevOps engineers are not a thing. But there is an engineering aspect of DevOps. Yes, DevOps is a collaborative methodology. DevOps is about developers and operations doing stuff together. But what is this stuff? There is something engineering there. There are a number of attempts to define what this engineering aspect of DevOps, how it is called. One of them is made by Google, and they call it SRE. SRE, there are a number of versions of how do you break down this acronym. The most, according to Google, the most profound one is Site Reliability Engineer. One of the reasons we have this terrible term of DevOps engineer is because no one wants to be a site reliability engineer. And they don't want to be a site reliability engineer because it sounds to people like this is people that take care of the website and make sure that it's up. This is what I heard. So in my previous job in JFrog, we had DevOps team, and I worked there, and it drove me mad every day. And I had many conversations with this team leader and the VP of engineering and CTO, and explaining them DevOps team is bad for us. We cannot have DevOps engineers, and they were asking me, well, how do you want to call them? And I'm like, there is a term for that. Watch this Google videos, it's an entire series of videos that explain how SRE implements DevOps. And Liz von Johns and Thes Vargo, very smart people. By the way, obviously the link is in speaking JBar, the link for all those videos. And I would just watch it. And they were like, yeah, of course we know about it. But when we tried to call those people site reliability engineers, we had a revolt on our hands. They are claiming that they are doing much more than just keeping the lights on the website. So really, no one wants to be an SRE because it sounds very limited. Now, I don't know if you noticed, in the last couple of years, there is a new term. It's called platform engineering. It's the rage now. Everybody wants to be a platform engineer. There is tons of discussions on how platform engineering is related to DevOps, 33, almost 34 million hits. And it's like, how platform engineering is different than DevOps? Well, because this is engineering and DevOps is not, you idiots. Platform engineering is different, where is the difference? And then like, people like all over the place. Platform engineering is that? Okay, so there is like an entire new thing. Is platform engineering the same as DevOps? No! I obviously ask ChatGPT, because that's what I do. Tomorrow, by the way, I have an entire session, and I'm going to ask ChatGPT what to do in code and do that. It's going to be, if anything, very funny. I have no idea what's going to happen. You're welcome to come and laugh with me and at me and at ChatGPT. But that's tomorrow. Today, what is platform engineering? I had to add in one sentence because it gave me like 3 pages. So in one sentence, platform engineering is the process of designing, building, maintaining the underlying infrastructure, including software platforms, systems, and services that software developers use to create and deploy applications more efficiently. Boom! This is the engineering aspect of DevOps. This is exactly the infrastructure that we all need to come together as a collaborative culture and move forward based on all that. This means that now we, the developers, can write code and then deploy it to production together with platform engineers, together with the testers and the QA people, together with the security people and the product people. We can collaborate on this platform that platform engineers create and maintain. This is it. So yes, every time you see a platform engineer, they actually mean SRE, but this is the good stuff. This is the right term. And if I ask the same folks that are our DevOps engineers, and I tell them, yeah, I understand you don't want to be an SRE because you think it's just maintaining the website. How about platform engineering? Yeah, we want to be platform engineers. This is awesome. And I'm like, great, problem solved. So yes, platform engineer, I consider it my personal win over the DevOps engineer term. And now, getting back to our list of DevOps people, which actually means platform engineers are happy, we can ask, what does it mean? How we can make platform engineers happy with our software, because we need it, as you just saw, that's exactly what we need. So what makes platform engineers happy? Our software is modular. Why it is important? Because if we need to release faster, we want to release smaller chunks of our software. Why we want to release faster? There are 2 main reasons. Two, the biggest one. The first is time to market. The faster we release, the more money we make. Well, 3 reasons. The second is security. Well, when we have an incident, we want to release the patch as fast as possible because our security depends on it, right? And the third is customer happiness. 2 aspects here. First is, if our product is done, we want to bring it up as fast as possible, and for that we need to release faster. And the second is experimentation. We want to try different things to see what our users like, because not only we don't know what they like, they don't know what they like. So asking them is useless. The only thing is giving them something and then see like, are they smiling or not? For that, we also need to release faster. So in a sentence, what makes platform engineers happy is releasing faster. For that, our software must be modular, easily deployable, right? So there is like not instructions or 50 pages of what you need to do exactly manually on the production servers in order to our software to work. It should be very easy to deployable, ideally automatic. We commit something, we accept that someone else accepts the pull request, next thing you know, this thing is in production. Or not, because it failed on quality gates, which is fine. But if everything is fine, it's in production. Observable, because we want to know when something went wrong, and we want to know if something is slow or anything like that, and we want to know what went wrong. Scalable, right? Auto-scaling, Kubernetes, the thing we want our software to be able to serve X amount today and 10x on Black Friday or whatever, right? So we need to be able to scale it to infinity. Upgradable, very important. We have a bug in production, we have a new version. How easy it is to upgrade to the new version. It includes a bunch of stuff, including stuff like how fast the current service can go down. What is the shutdown time? The shorter shutdown time is, the shorter the entire upgrade cycle is. And obviously how fast it is loading, how fast it's going up. But also downgradable. Sometimes we have a bug and there is no easy fix. Instead of going up a version, we want to go down a version, which sounds like, well, not a big deal, but remember modular, microservices and what's not? Chances are your current services won't be able to work with this service that we are downgrading because they are backwards compatible but not forward compatible. So they should be forward compatible as well. So there is a lot of things here. And the good news are that this also looks very familiar, at least to me, maybe to some of you. Anyone recognizes the list, like what it feels like? What it feels like? A very, again, very popular resource out there. 12-factor app. Sorry about that Zoom thing. It says 12-factor app. This is a relatively old resource by now, and there are a lot of new iterations on it beyond the 12-factor app, the 16, 18, whatever factor app, that describe how modern software should be written in order to run in cloud, be scalable, be upgradable, and generally make your platform engineers happy. And the list here, it's from a different perspective, but in the end of the day, it's all the same. Right, concurrency for scaling, port binding for modularity, that's your microservices part. Build, release, run, this is your deployable that you build and then it releases and runs. Logs, this is the observability part. Everything here may be called different and looked at from a different aspect, but in the end of the day, this is all for the same purpose. Another term very popular for this kind of software is cloud native apps. Cloud native apps is also about that. It's how your apps can live in the cloud, and that means they are scalable, they are upgradable, they are microservices and what's not. Again, same idea. So basically, what is our responsibility in this DevOps cycle is not necessarily the operations part of the cycle, is creating software that we, together with platform engineering, will be able to operate successfully. So this is kind of our participation in DevOps. Now, I tell this story for many years now, and it's not going very well. That's me trying to convince developers doing something DevOps related. Doesn't really go very well. DevOps is around for 12 years. Developers are still not very excited about it. I might make you feel a little bit better about DevOps, maybe not. And it means that something is still missing. How do we go from developers not being excited about DevOps to developers that are happy and productive working on the type of software that we just spoke about? Interesting fact. I was trying really hard to look for an animated GIF of someone who goes from sad to happy. It does not exist. There are tons of GIFs of someone who started smiling and ended up crying. Not a single one the other way around. This is the reverse GIF of her first laughing and then crying. I don't know why. I think I might know why. And it will be, for us, about looking at DevOps from different perspectives. In the early days of DevOps, this was kind of the picture of DevOps. There was like Dev and Ops and QA coming together into DevOps, and then a unicorn ponies farting rainbows. It doesn't work because this is absolutely meaningless. What does it mean? What do you want to tell me? Do you want to tell me that you need to learn Dev, Ops, and QA and become this superhuman DevOps engineer? We spoke about it, they do not exist. If they do, Netflix already hired them, too late. Not gonna happen. So instead, we should look at DevOps differently. And the way to look at DevOps is, it's a collaboration of people having a collaborative process and working with tools that help them achieve their goal. And if we think back about what we spoke about, it actually makes sense, right? So we have people from different departments. They have this collaborative process of DevOps. They know they need to work together to release software and release it better. And they do it using the tools that, as we learned, platform engineers make accessible to us, which is great. So basically, we need productive people collaborating on productive process using this productive tools. Some of it is nailed down. So obviously, productive process, we know exactly what it is. Empowered teams is the basic component of DevOps from day one. What does it mean, empowered teams? It means we don't have the silo of dev team and ops team, or God forbid DevOps team, and QA team, and everybody just throw the software one after another. Instead, we have people working together in a single team. We have developers on the team, we have testers on the team, we have platform engineers that take care of infrastructure, and then everybody are releasing their software together. This is the concept of empowered teams. For those rare companies that manage to implement it, it works great. So we have this now. Tools, well, you can argue that YAML is probably not the most productive tool out there, but on a grand scheme of things, we know which tools make platform engineers effective, right? It's infrastructure as code, mostly. It's considering everything code, the servers, you remember Kettle on pads and all this stuff. And this is how they are productive in releasing software. And we as an industry made a tremendous progress on this front. Remember 12 years ago, 10 years ago, software that was released once in a quarter, once in half a year. Today, most of the software in the world, and it's amazing the progress that we made, is released multiple times a day, or at least multiple times a week. And this is thanks to infrastructure as code as concept. And the idea is that servers are code as well. So we do nail a very effective tooling, although sometimes it doesn't look like it, especially after 3 hours of staring at a YAML file and not understanding why the fuck it doesn't work. Productive people This is, for me at least, an open question. How do we make people, especially the developers, more productive and bringing them to the same nirvana of DevOps? And the pain is real. Gradle did multiple surveys of pains of developer productivity. 90% expressed challenges with too much time spent waiting on build and test feedback. Let's play a game. Who knows how long their build is? No, but ballpark. Like, is it minutes? Is it hours? Is it seconds? All of you know? Most of you know? Okay. Out of those, first of all, how do you define build time? Does it include tests? Who thinks that build should include tests? Excellent. Who thinks that we can do a skip test sometime, especially on a local machine? It's fine. No? Okay, good. How many have build which is less than 10 minutes? Oh, more than half. Less than 10 minutes with all the tests. Like the complete thing, less than 10 minutes. Very good. How many of you have build that is faster than 5 minutes? One hand. So, but most of you are between 5 and 10 minutes. Who thinks it's short? I think it's short. It could be an hour. So 7 minutes is not bad at all. Obviously, you all think it's long. You think it's long because when you develop locally, for those 7 minutes, you either sit and stare at your screen, or you go and do something else. Which one is worse, by the way? Who thinks that staring is worse than doing something else? Half. Who thinks that starting something else is worse? Yeah, half and half. Yeah, because they're both terrible, right? Starting something else is actually worse because you're doing a context switch, and that's the one single most production demolition thing you can do for your productivity. It's terrible because context switches are very, 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 very expensive mentally, and when you do them too much, you just switch to the mode in which you are much less creative when you actually need to write code. Staring at the screen for 5 minutes is no joke. So there is no good answer here. You are here with those people, and it's not surprising. Developer pains are widespread. Too much time spent waiting on build and test feedback, either locally or CI, we're right here. But also, inability to easily troubleshoot and determine the root cause of build failure. Build failed. What happened? About 35% of the time we know, but 65% of the time we might not. How about flaky tests? Who loves flaky tests? They are the best, right? Flaky tests are great. So, and then insufficient observability of analytics on build and test performance and regressions. And this is basically our build was 5 minutes last week, and it was nah, but okay. Now it's 15. What the fuck happened? I have no idea, right? But 15 is really not okay. So, as I already mentioned in my talk tomorrow, what we're going to do is we're going to ask ChatGPT on how to solve all those, and we're going to see what happens. That's going to be epic. But for now, trust me when I'm saying the pain is real. And the way to solve it is to introduce into our DevOps engineering chart. And this is the engineering chart. This is the solutions, right? This is your Kubernetes. This is how we work in teams. Another engineering aspect, which is developer productivity engineering. Developer productivity engineering for developers is as infrastructure as code for platform engineers. This is how we become more productive in creating software as developers. Platform engineers are more productive in creating software by streamlining the release process and observability and everything else, We become more productive in creating software by doing developer engineering. What does it mean? So here is a little bit of tenets of developer productivity engineering as we see it. So the first is foster faster feedback. This is why you run builds. This is why you compile your code. You write your source code and you're like, did I make any mistakes? Will it work? Let's compile it. And the compilation part is kind of sorted out, right? How many of you use integrated development environment? IntelliJ, Eclipse, VS Code, whatever? Everybody. Why? Because it does exactly that. Whether if you run a special command to compile, or you just save your file, or you don't do anything like with JetBrains software that just do it all the time for you. And then you see those red marks that, hey, here I forgot a semicolon. This is feedback. And it is immediate, and this is sweet. But obviously, compiled software, as opposite to some developers' beliefs, doesn't mean that it doesn't have bugs. For that, we write tests. And then we run those tests in order to get the same feedback. It's actually exactly the same. Whether I forgot the semicolon or I inverted an if condition produces the same result, unusable software. But for some reason, we expect immediate feedback on the first one and are ready to wait for 7 minutes to get the feedback on the second one. It doesn't make any sense. It's literally the same class of problems. So it should be faster to immediate for both of them. It will prevent us from doing the context switching or wasting our time, depends on your poison while you wait for your build, whether you will do something else or will stay on the screen. And actively eliminating those wait times should be the goal of developer productivity engineering. Actively fighting, making the build not just faster, but as fast as possible because it is critical. Tools and platform that promote transparency and, that would be eliminate tools for developers, that's that. That's where we fight, right? When we actively fight those builds that are long and should be shorter, and when we fight the builds that used to be shorter, but now for some reason longer. Collaborating through effective tooling. What this has to do with anything? Well, this is also about our productivity. None of us work alone. None of us is working in vacuum. We need to collaborate. And collaborate through effective tooling, what does it mean? Slack? Well, maybe. If Slack is effective for you, that's a tool in developer productivity engineering. But it also might be stuff like, how do I send this pointer in code directly to the IDE of my colleague because I need them to see something? Can it pop up in their IDE? Well, with IntelliJ, it can. With other IDEs, it can't. Which one will make us more productive? Here's your answer, right? Can we send our colleague a link to a point in the build run that will show them something that we want them to see? Can you do it with your terminal output? How are they gonna do it? Screenshot? Or you can point them to the page that will open the precise point in build with explanations, what happened, what went wrong, why suddenly it takes 1 minute instead of 10 seconds, this kind of stuff. This is what I'm talking about. What else? Prioritize automation and eliminate bottlenecks. This is straight from DevOps book, right? This is what DevOps is about. But DevOps talks about it. As you remember, it's an ops people plot. All they care about is ops. So what they talk about, prioritize automation and eliminate bottlenecks. What are they talking about? The release cycle. How can we build this pipeline that goes through CI, CD in production? But we have those problems as developers as well. And here for us to eliminate bottlenecks and prioritize automation is as important. For example, and this is what I already mentioned, how do you make your software compile? Do you have do you need to go with the mouse and tap something? Or you have a shortcut? Or it's enough for you to just save the file? Or it's just automation to the level you don't even recognize it, because once this window loses focus, what it's going to do is to compile. This is that. We automate everything to the level that is possible. And yes, probably the toil of saving the file with Command S and just losing the focus on the file is tiny. But this is what we do all day, every day. In the end of the day, like with the builds, it will build to significant benefits in developer productivity. Observability and proactive improvement. We spoke about how can we see that we have a regression in our build test cycles. Obviously, if it was 5 minutes and now it's 15 minutes, we will notice. But what if today it's 5 minutes, tomorrow it's 5 minutes and 10 seconds, and in a week is 6 minutes? Sounds not very significant, but again, it sets up and it slides. How do we make sure that we see this problem and then fix it in time before it becomes an even bigger problem? Dedicated organizational mindset. Now, this is something that, for me at least, when I first heard about developer productivity engineering, was very counterintuitive because of my DevOps background. You remember, DevOps is about everybody doing DevOps. It's about empowered teams. It's about not having DevOps engineers or DevOps team. And it works because everybody feel every day what it is to release faster or slower or more successfully or with regressions, and it's top on everybody's mind how to make it better. Developer productivity engineering is different. It's none of any of our jobs on the daily basis to work on the build and make it faster, to find flaky tests and eliminate them. We feel the pain when the build is slow. We feel the pain when there are flaky tests. But none of us will probably run and make their day about doing something about it. We'll probably complain about it. And then run this flaky test one more, see it passes, and move on. And it's fine, because this is not what we do. Dedicated organizational mindset means that we will have team dedicated for improving developer experience in general and developer productivity in particular. It will be on top of mind of the organization that we need this team. And when we have those special people whose day is about how do we make faster feedback, how do we eliminate flakiness, how do we observe that the local build times aren't sliding, this is where the magic happens, and whatever you are frustrated about is getting solved. Now, the collaboration suddenly makes also much more importance, because now it's you collaborating with them. How can you tell them that this particular test is flaky? How can you express that suddenly your local build time is higher? This is why we need that collaboration. And last but not least, outcomes over output. And this is true for everything else. how do we concentrate on what's really important instead of just gathering information and noise? How do we resist the noise? Now, this is all not relatively new, much newer than DevOps, but not really new. There are great organizations all around us that actually already doing that. And we can see here that developer productivity engineering dramatically improves productivity. Almost every organization agreed that since integrating developer productivity engineering into our development process, the time savings we experience on build and test cycle times have dramatically improved developer productivity. This shit really works. 84%. Same amount, because they're probably the same people says yes, say developer productivity engineering fosters developer joy. Hey, when was the last time someone in your organization cared about your joy as a developer? When you have developer productivity, someone who takes care about developer productivity engineering, this actually happens. So, what we spoke about today are two evolutionary concepts. DevOps is evolution that came out of a need of eliminating silos. Yes, the first pain was, the first who felt the pain were ops people. But we understand that the goal of delivering better software faster is for all of us. So DevOps is an evolution. Yes, it was awkward in the beginning. We felt like they're dragging us into doing their job. But we're figuring it out. Platform engineering is a huge step. We now understand how we work together in empowered teams. And the second evolution is developer productivity engineering. And this is, again, a grassroots movement, if you wish, because the developers feel the pain of being less productive because stupid shit that should be solved out, like flaky tests. There is no reason to have flaky tests. The only reason is there are and no one will take care of it. So let's change it. Let's have someone who takes care of it. And the best organizations out there, like your Netflix, your Meta, I'm just calling Meta best organization, engineering-wise, sorry about that, right? And like your Amazons, the people who really figured out how to write software, they are the ones who kind of are in the front line of the developer productivity engineering movement. And in September, Grail organizes DP Summit, Developer Productivity Engineering Summit in San Francisco, where you can hear a lot of those stories and learn a lot of how to actually do it and how to promote it in your organization. And there's early bird. You know where to find the link? You know where to find the link? Yeah. All right. So DevOps, SRE, project engineering, platform engineering, developer engineering, what's going on? So yes, DevOps started as solved ops concepts, but ops concerns are everybody's concerns. We cannot disregard it. It's a collaborative methodology. It needs engineering implementation, and it actually has one. Call it SRE, call it platform engineering. Someone has to write all those YAML files in the end of the day. Right, and those are people who make our release cycles productive. But who makes us productive? That will be your developer productivity engineering. It has the answer, and that's the other pillar of DevOps engineering implementation. And with that, thank you very much. We have time for questions. And you can find me on Twitter, whatever today's replacement for Twitter, @jbaruch. And don't forget speaking.jbaruch. The slides, the video, all the links, some stuff that I didn't even speak about, like trying out DPE on your build and seeing what it does for you. This kind of stuff is also there. Thank you. Now we can have questions, or we can get a head start on the break. Completely up to you. Any questions? I'm going to unmute my Zoom, so if the two people on Zoom with us have questions, we will hear them as well. Yes?
So, what is dedicated organization mindset team
paid this lately. I did. Now it's going to be product pitch because Gradle pays for me being here, so I'm going to pay them back. There are actually a number of tools that are dedicated significantly on development for productivity engineering. Some of them are ones that you don't even think as special tools. For example, the ID that I mentioned, right? And JetBrains tools are kind of the head spearing this. Everything in IntelliJ is about how can we make you more productive. Everything. So this is for me the golden standard of a tool that promotes development productivity engineering. The other one, it's a product currently known as Gradle Enterprise. And it's going to be renamed soon because Gradle Enterprise is a terrible name. This tool has very little to do with Gradle and has very little to do with Enterprise. But it is what it is. So what does the tool do? First of all, it connects to your build, whatever it is in the JVM ecosystem. It might be Gradle, it might be Maven, it might be Bazel, it might be SBT, we're releasing SBT very soon. And it collects the data of what's going on in this build. Much more than you will see in your app. And all this data is available to you. You can go there. Well, this is how the build looks like. Did it fail? Did it pass? Why did it fail? This failed because something with other developer do. Can I take the link to this particular error and send it to them? Yes, you can, and you should. And then you can start working on your build. Let's look at performance. Which tasks are slow? Why are they slow? What can we do with it? Can we cache those tasks and not run them even if we do clean builds? Will the other developer benefit from my cache? I cached this task. They have exactly the same build. They don't have to run it because I cached it. So they will use my cache for that as well. Tests. Do we really need to run this test? Well, in this module, but it has nothing to do with what we changed. Today, even with incremental builds, if we change the source code implementation of a method, the test will run. Even if the source code was adding a log file. Will it affect the test? It won't. Will the test run? For now, yes. Can we do something about it? Sure. What can we do? AI. We can train the model and teach it that when we add logs, we actually don't have to run this test again. Maybe in some environments we will. We definitely will do it on CI server going to production. But do we need to run it now in my local build? Or can I go from 5 minutes, because most of it's test, to under 1 minute because I don't need to write this test, to run this test, even if I change something in the source, right? And then, okay, how about I have a lot of tests that I have to run, but maybe I can run them parallelized on my machine. Will it do it good? Will it do it bad? Let's try it. Maybe it's worth it. Maybe my machine is not enough. How about using it in cloud? How many of you know that your CI infrastructure have parallelized tests? A couple of people. Well, it's a known technique, right? Does it help you on your local machine? No. Can it? Yes. If you have the right tools, you can run tests in parallel in the cloud that will speed up your local build. This is another thing, right? And then everything that the DevOps, the DPE team is looking for. Regressions, graphs, trends. The builds across the organization run 10 seconds longer this week. What happened? Let's check. So all this and this tool you can start today, but if it's something that's really interesting, come to my talk tomorrow and I will show you a little bit of that. And as I mentioned, it's going to be hilarious because we're going to do it without any tools, except of ChatGPT. ChatGPT will tell me how to make my build more efficient. It's going to be hilarious. So yeah, there are other tools as well, but around writing code and building code and testing code, this is where we're kind of playing, and those are the areas. Yes?
I was going to ask, how can platform engineers help with regards to, like, I know they can set up the infrastructure for it, but how can they help with stuff internal to the team, like for flaky tests.
Yeah.
How would a platform engineer how to fix it? How do they know?
This is an excellent question. So flaky tests are the domain of developer productivity engineering. Developer productivity engineering are different people. They are not the platform engineers. Platform engineers write YAML files.
Oh, right.
Platform engineers will tell you, hey, you know what? Your application takes too long to start up, and this impedes our upgrade processes. Instead of our upgrade process would take 5 minutes, now it takes 10 because your WebSphere crap is too slow. And then you go like, okay, I don't need it anymore, I'm going to do Spring Boot, whatever. Like micro now, right? This is platform engineering. This is about how your code behaves in production. Developer productivity engineering is about how effective are you in writing the code, whether it's crap WebSphere or it's awesome Quarkus macro or what's not. It has nothing to do with what the code that you are writing and whether the platform engineers are happy with the code that you are writing. It's about how effective you are in writing it. And those people, developer productivity engineers, will find your flaky test for you.
So there would be a separate team that would come in and basically say, read your code, look at it, okay.
Exactly. Now, how do they know? Because they have those tools that observe your builds and determine the flaky tests, and then come back to you and say, hey, did you know at all that you have flaky tests? And you're like, oh, maybe that sometimes, but I just run it again and it's fine. And they're like, no, let's figure it out. This test is flaky. Take a look at it. Let's figure out why it is. Let's fix it for you and for everybody else. Sounds good, right? Yeah.
So, one of the things we're struggling right now in getting the DPU team off the ground is diversification of like a polyglot ecosystem.
Yeah.
And also of tooling. So without a common kind of enabler of a single set of tools that we use, it's hard to make a wider, broader impact.
So
Other than reducing or putting some guardrails around the diversification.
Yeah.
Any thoughts on?
Yeah, absolutely. So obviously you are spot on. The developer productivity engineering tooling is very technology specific, right? The way you optimize your build and the way you run tests is completely different between your Python and your Java apps. And again, look at the pinnacle of developer productivity engineering, your IDE. Yes, there are some similarities between IntelliJ and your PyCharm, but they are essentially different tools. And there were years between when one was released and the other was released because they had to do all this work of, okay, how you write Java productively to how you write Python productively, and those are different things. And code is actually the easy part because the basics of code writing is the same. You have the abstract syntax tree that you need to analyze and see what you can do and what's not. When it comes to build and test, those are radically different concepts in most of polyglot on different languages. So having one tool that will answer all of them is even less possible than having one tool for code writing. What we can do about it? First of all, yes, development engineering team will probably have a hard time supporting different languages, and there is no way around it. Then you invest more in that, you find better tools, in the end of the day, probably on this team, you will have people that are in charge for different stacks and will be expert in that. There is no way around it. Guardrails are great. What you do is, okay, we have a stack that is state of the art in terms of our support for developer productivity engineering. Let's say Java over Gradle built in whatever is today the GitHub Actions and released into like whatever AWS. We nailed this part. You will get the best tools, you will get the best support, we will be on top of it. If your build is faster than you blink, we will be on top of it and we will fix it. We know how to do this shit, it's all figured out. Now, if you prefer Python, fine, we understand. Maybe you have, data engineers, and this is all they know, and there is no way for them to learn Java. Their head will explode if they try to learn anything other than Python. Constraints are constraints. In Python world, we have okay tooling for developer productivity engineering, but you will have to excuse us if it's not perfect as in Java. And now it's your call. You do you. And if you want to do Rust, good luck. Come to us in a year with a successful project that is now de facto part of our organization, and we will look if there is something we can help. And maybe the year later, we will have the best tooling for developer productivity engineering in Rust, because this is the most important part for the company. But for now, you do it on your own risk. So this is what usually works.
Yeah, and that's kind of the approach we're taking. I was hoping you're going to be like, there's a silver bullet, Greater Enterprise is going fully polyglot.
Yeah,
I know
JVM.
you're expanding to more languages,
Yes.
but is it just JVM focused?
For now, yes. Bazel, kind of your window into everything else. But I mean, if you do Bazel for not like Java, you will have some support on Grail languages. But yeah, so obviously we will expand, and there are other tools, other players for different languages that we are not directly competing at the moment. So you do what you can do. The importance of a separate team here is kind of, once again, right? If you do it on the way, you probably will say, you know what, that's just another tool I don't have bandwidth because I need to do other stuff. But this, if developer productivity engineering is what you do, is your job to find solutions, even for the stuff which is not obvious, like on the shelf and immediately available.
Where we are right now in early inception of our team, we're also theorizing that there's a lot of influence that the team has to other teams. Like even influencing platform engineering, you say like your documentation sucks. Here's some ideas on how to fix that.
Of course. In the end of the day, they are platform engineers are people who look at ops problems as it was software. Infrastructure as code. Code, they write code, they need developer engineering. Immediately. They have tests for their whatever Terraform scripts. Are their tests slow or they're fast? Can we help them or not? Platform engineers write code, they need support of our team. Right there.
While they're kind of in the middle as a balance, it sounds like you're saying to position the DB team closer in terms of empathy towards the delivery teams that write the code.
Yeah, so with developer teams it's very easy. Developer teams feel the pain every day. You all feel the pain, you saw the survey, everybody feels the pain. You're gonna have them, hey, I'm going to actually monitor, find, and help you fix your flag test. Yes, take my money. Platform engineers, Linux administrators who learn Gits, they're like, I don't know what you are doing, I'm not really, what flaky tests, I don't know. So it's a harder sale. But in the end of the day, they are software engineers in some shape or form. They will benefit from developer productivity engineering as well. All right? Excellent. We still get a head start on this break. Thank you very much.
Thank you.
Let's see if I got the video right. In any case, at least I have the recording from Zoom, but let's see if I got this one. Yes! Excellent.